Hi guys, very good evening. Welcome to Gradeup, India's largest e-learning platform. Okay, so today I am coming up with the part 2 of this series, score booster series of NIELIT. So that is synthesis of combinational circuits. So in the previous session, we have discussed about how to represent numbers and also some problems related to minimization of logic functions. Now, today our discussion is about the combinational circuits, which includes multiplexers, decoders, full adders, half adders, all those things. So the connected arrangement of different logic gates is nothing but a combinational circuit. So synthesis is nothing but, so for certain inputs, so what will be the output you are getting. So analysis of the combinational circuits, including multiplexers, decoders and other combination circuit. So very good evening, Sonal Priya. Vishnu, good evening. Vinay Max, good evening. Saket, good evening. Ajit Yadav, good evening. Okay. So before discussing the concept, just I will introduce myself. Just before that, I will tell you one thing regarding this YouTube channel. So for the Gradeup right now, more than 3 lakh subscribers are there. You can also just subscribe onto the button, and also you can like the channel if you really like it. As you can also share your friends regarding this YouTube channel, because we are offering a lot of things like a score booster series for NIELIT we are offering, and also we are giving different lectures on the IIT Bombay previous questions, and also multiple selective questions that are newly introduced with IIT Bombay 2021. Those series are also there, and some special topics related to some individual subjects and individual topics are also we are giving. Please subscribe to the channel and like the channel, and also download the Gradeup app, and you can see a lot of free videos going on, free series is going on in the app also. So you can go there and you can watch the lectures. And so there are a lot of courses are also there. I will just introduce the courses we are offering also. So just introduce all these things to your friends also, whoever you know, so that they also will get advantage and benefit out of this. Okay. So before starting the discussion, let me introduce myself. Myself, Murali Krishna. I am having 20 years of teaching experience, both in the GATE and also I worked in different engineering colleges. And I am topper in one of the NPTEL course that is conducted by IIT Kharagpur in the year 2019. And I stood top with 96% of marks, Elite Gold's topper certification I got. And also I am certified as International Engineering Educator through the IJIP, Institute for International Engineering Education Certification Program. And also the qualified in the GATE exam, and trained more than 50,000 students across the country for the last 20 years. And in different areas of computer science and engineering. So different core areas actually. So those are theory of computation, operating systems, computer organization and architecture, computer networks, and digital logic design. So these are the subjects where I am familiar with. I hope you will enjoy the session. So basically this session of this series of the score booster for the NIELIT, for improving your score in the NIELIT exam. Just in a nutshell, some of the questions whatever are important. So especially in digital logic, very simple questions will come. Already we have discussed in yesterday. So gate level, one more question level questions you can prepare, so that will be sufficient. Okay. So I hope every one of you will enjoy the session. So Sindhu, good evening, and Aditya, good evening. Triveni, good evening. Raji, good evening. Akash, good evening. Jahnavi, good evening. Jamal, good evening. Pooja, good evening. Okay. So now let us discuss the different courses we are offering here at Gradeup. So taking coaching for computer science GATE is sufficient for preparing for ISRO and also BARC, NIELIT and the DRDO. These 4 PSUs are separately conducting their examinations for the computer science students for recruiting the candidates. Okay. So that is ISRO, BARC, NIELIT and DRDO. And all other PSUs who are recruiting the CSE people, they are offering the jobs based on the GATE score. Okay. GATE computer science you have to appear, and based on the score, the different PSUs are taking the candidates. Okay. And there is no other exam they will conduct. Maybe directly they will conduct interview. Some companies will conduct a group discussion and then recruit the candidates. Okay. So computer science GATE is a huge competition is there in coming days, because a lot of engineering colleges are offering a more number of batches in computer science. Different variety of courses are coming up in MTech, like machine learning, deep learning, and there are so many other branches of computer science are coming up. So there is a huge demand for the computer science. So one has to write the national level exam for proving yourself that you are really stamped engineer. Okay. So right now for computer science, we are offering 3 courses. One is a gear up, and other one is a rank up, other one is a vision. So this gear up and rank up are the short-term programs targeting on the year 2021 gate, and rank up also 2021, but vision is 2022 gate. So this is the year-long program. So 1 year of yearly coaching will be there, live classes we will conduct. And this gear up, this is basically designed for the students who wanted to revise the entire gate syllabus and also wanted to learn the basics fundamentals very clearly. So this gear up is useful. So as far as the rank up is concerned, this is designed for the score improvement. So that is for the people who are repeating the gate exam, something like to improve the score better than the earlier what you have got. So this rank up is designed. It is a, we can say, fast track revision course, more emphasis on the problem solving techniques, and more tough problems will be solved here, and also some theory questions also will be discussed. Okay. And in gear up and rank up, we are offering 300 plus hours of live classes, 3000 plus practice questions, and 40 plus mock tests, and 75 plus chapter wise study notes. And here also rank up also same, but more emphasis on the problems. A vision is a year-long program, and it is ideal for second and third year students, because the preparation for gate should start from the second year. All the core engineering subjects will start from the second year. By the time you come to the third year for writing gate or for final year, you can finish all the core subjects. You can concentrate on the other aspects also. So this is how the course is designed. But anybody can join any of the courses. Just we are telling ideal conditions, like rank up is ideal for the repeaters, and gear up is ideal for the revision of the syllabus, something like that. Okay. But there is no barrier for any student to join any of the course. Even employees or working people also can join. There is no issue. And this is in vision course, we are nearly 600 hours of live classes, and 5000 plus practice questions, 100 plus mock test, and 100 plus chapter wise study notes we are offering. Okay. And if you subscribe to the Gradeup Super, you can have an access to all the structured live courses unlimitedly, and also you can get the mock test. Okay. And for any doubts related to this, you can reach us at 96500529904, or you can also mail us at help@gradeup.co. Okay, that's all about the courses we are offering here. And the next is faculty. We are having 4 faculty members right now, and some more faculty members are adding up, top faculty members. And myself is one of the faculty member. I am having 20 plus years of experience, already I told you. And Satyanarayan sir is having 13 plus years of experience. And Ankit Doyla sir is having 8 plus years of experience, and Navinit Gupta sir is having 7 plus years of teaching experience. So all these people are expert in their respective domains, and try to interact with these people after joining. Okay. So I hope you will enjoy the session. So what I have planned for this is, I have brought some of the questions on the combinational circuit, so which are at a 1 mark level of the gate exam. So most of the questions that I came for the NIELIT are level of 1 mark in the gate exam, and sometimes a little bit more also. Okay. So Gopal Krishna, good evening. Okay. And Pratik Soni, good evening. Raj, good evening. Abhishek Naik, good evening. Very happy to see all of you. So I hope you will take advantage of this session and prepare well, and you will get the top score in the NIELIT. So that is what my wish. And let us start the first question. Question number 1. So meanwhile, you can subscribe to the channel if you are not yet subscribed, and you can also like the channel if you are really liking it. A lot of free videos are going on, and you can also make an advantage of having the Gradeup app also. From the Play Store, you can download the app, and you can get all the free videos. And some series are some innovative series we are planning for the app also. So try to get an advantage of all these benefits. Okay. So which of the following logic gates are called universal building blocks? Option A, OR, AND gate. Option B, XOR, XNOR gate. Option C, NAND and NOR gates. Option D, none of these. Yeah, many of you are sending option C. Yes, option C is the right option. Okay, this is very simple question. So universal building block means any type of circuit can be realized using the NAND and NOR gates. Any type of circuit can be realized using the NAND gate and NOR gate. I hope you are understanding. Is my audio, video, everything is clear? Please confirm once. Either Gopal Krishna, Pratik Soni, somebody please confirm me. Only one person is sufficient, rather than sending messages, series of messages. I am just naming Gopal Krishna or Pratik Soni. Can you confirm once? Is my audio and video, everything is fine? Okay. So universal building blocks means any type of logic gate can be realized using these gates, NAND gate and NOR gates. Say for instance, just for as a support of that, yes, fine. Thank you, Sonal Priya. Okay. So now let us suppose we are taking the OR gate. Okay. I wanted to realize the OR gate with a NAND gate. It is possible. Okay. So what is OR operation? If X and Y are the two Boolean variables, OR is nothing but X plus Y. OR is nothing but X plus Y. Okay. I wanted to realize this OR gate by using the NAND gate. By using the NAND gate. Just to support this, I am telling you how to implement this. Let us suppose I am taking X and X is given for a NAND gate. Okay. So both the inputs for the NAND gate is X only. Okay. And Y is also given for NAND gate, and both the inputs for the NAND gate is Y only, and this output is a NAND operation, and these two will be given for another NAND gate. Okay, like this. What do you mean by NAND gate? And followed by complementation and invert. So X and X is X only and X invert. So this will become X bar, because AND operation will be X and X whole bar. X and X is X only according to Boolean algebra. So this is X dash. Similarly, this will become Y dash. So as the logical AND operation, use X dash and Y dash and whole dash, because NAND operation is whole dash. So it is something like AB whole dash. AB whole dash is nothing but what? A dash plus B dash. So that is nothing but X dash whole dash plus Y dash whole dash. X dash whole dash plus Y dash whole dash. This is nothing but X plus Y. So we are realizing the OR gate making use of the three NAND gates. I hope you understood how this NAND gate is used to realize any type of circuit. Okay. So that's why these circuits, NAND circuit and NOR circuits, are called universal building blocks. Okay. Option C is the right option. I hope every one of you got through this. Okay. Yes. Thank you, Gopal, Krishna, and others. Those who are responded, very nice. Okay. And every one of you, most of you sent. I think you are in sync with me, and you are in very good in preparation style. Okay. Now let us go for the next question. It is little bit more. It is analysis, synthesis. Okay. What do you mean by synthesis? Actually, we are having a syllabus like design and synthesis of combinational circuit and sequential circuit. Design is nothing but based on the requirement. We have to take the truth tables, and requirements will be taken, and accordingly logic diagram will be constructed. Synthesis means we have to analyze the logic circuit for certain inputs, what output you are getting. Okay, this is one type of the analysis on the multiplexers. So you know multiplexer. A multiplexer is a combinational circuit. Okay, it takes 2 power n inputs and 1 outputs. Am I right? 2 power n cross 1. So there can be n selection lines. Number of inputs will be 2 power n, and for n selection lines there will be 1 output. Output can be equal to any of one input based on the selection lines. Output can be equal to any of one input based on the selection lines. Okay. For example, if I take a 2 by 1 multiplexer, functionality of 2 by 1 multiplexer I will roughly explain here to understand this better. So 2 by 1 multiplexer is nothing but 2 power 1 cross 1, so that there can be only one selection line and there can be two inputs. Let us suppose the two inputs are something like I0 and I1 for instance, and output is Y for example. Output Y depends on the selection line. If selection line is 0, that is S bar, so I0 will be taken. If the selection line is 1, that is S value 1 indicates yes, then I1 will be taken. So that is Y is equal to S bar I0 plus S I1. So either if it is 0, Y can be equal to I0. When S is 1, Y can be equal to I1. So that is what the selection. Okay. Similarly, for this multiplexer, the C is the selection line. When C is 0, that is nothing but C bar. When C is 0, output is equal to A. When C is 1, output is equal to B. So the first output what you are getting is given as input to the next multiplexer. Am I right? So C bar A plus CB. So this is C bar A plus CB. So this is the input for the next multiplexer. C bar A plus CB. Now for this the selection line is D. Okay. Whenever D is 0, output is equal to first input. What is the first input? C bar A plus CB. Okay. So when D is 0, that is nothing but D bar. So D bar of C bar A plus CB. Okay. Plus when D is 1, output is equal to 1. So D dot 1 is D. So that we can call this as a D bar C bar A plus D bar CB plus D. So this is what output here. Okay. When D is 0, output is equal to C bar A plus CB. When D is 1, output is equal to 1. So here what you are getting is this. Okay. Now this selection line is based on the D value. So whenever the D value is 0, for example, whenever the D value is 0, so this D bar of 1, because output is equal to first input. What is the first input for this? This selection line is taken as a D actually. When D is 0, output is equal to 1. So D bar dot 1 plus when D is 1, for example. So this is the D of this one will be taken. What is this one? It is D bar C bar A plus D bar CB plus D. Okay, when D is 1. So when you expand this, DD bar becomes 0. This DD bar also becomes 0. Okay, and this is D into D becomes D. So finally it is a D bar plus D. So D bar plus D becomes 1. So finally the output function of 4 variables A, B, C, D has become 1. So the right answer for this is 1. Options not given. There can be some, definitely options will be there. So exactly, most of you have given D bar plus D. Congratulations. Gopal Krishna, Jamal Ahmad, Anku Kashyap, Akash Sanket, sorry, Sindhu Bandaru and Vishnu. Okay. These are the analysis of this multiplexers. Okay. I hope you have understood this. Okay. Is it clear? Okay. Now let us move on to the next. Third question. Consider the following circuit. So there is a circuit here. So what you have to do is to implement the function using the 2x1 multiplexer with A as a selection line, determine the value of I0 and I1 respectively of the multiplexer. So we are supposed to implement this with the help of multiplexer. Okay. Now if you observe what is the output of this function, based on that we can select the multiplexer and its value. Is it clear? Okay. Now one input is 1 for the OR gate. Other input is doesn't matter, whatever is other input, output will be 1. So one input for the AND gate is 1. For this OR gate, one input is B. This cross indicates when the lines are crossover, we are represented like this. So A complement, this is the A bar. So the output of this is, as it is a OR gate, so it is A bar plus B. A bar plus B and 1. So output is A bar plus B only. This is A bar plus B only. Now I have to implement A bar plus B with the 2x1 multiplexer, and A is taken as a selection line. Then what should be I0 and I1? So for example, this is the 2x1 multiplexer. Listen carefully. So in a 2x1 multiplexer, we can have only one selection line, and that is mentioned as A. And what are the inputs? I0 and I1. I0 is the first input and I1 is the second input. Okay. Now usually the output Y is equal to either I0 or I1 based on the A value. For example, A is equal to 0, so A bar, then output is equal to I0. Or if A is equal to 1, that is A, output Y is equal to I1. So Y value is like this. Now what is Y? It has to be equalized to A bar plus B. It has to be equalized to A bar plus B. Okay. Now what is to be applied here? So I wanted to get A bar plus B, right? Okay. So A I1. Okay. So what I have to take is, what is the question he has asked? To implement the function using 2x1 multiplexer with A as a selection line, determine the value of I0 and I1. So finally we got A bar plus B, right? So A bar plus B means we are supposed to get I0 as 1, because I am getting A bar dot 1 plus AB, let us suppose. B value, I am taking I1 value as B. Okay. Now A bar dot 1 is A bar only plus AB. Now what I can do, this can be written as A bar plus A, because A plus BC can be written as A plus B into A plus C from the De Morgan's. So A bar plus A into A bar plus B. A bar plus A becomes 1, so we get A bar plus B. 1 into A bar plus B is nothing but A bar plus B. So A bar plus B is the output. So that means, what is I0 value? I0 value should be 1 and I1 value should be B. 1 comma B. So option B is the right option. Exactly. 1 comma B. Gopal Krishna and others also sent. Okay. Thank you for your response. Yes, by distributive law. Now coming to the fourth question. Fourth question is also again with the multiplexer. So I have to be careful about this question. So it is very having complex this thing. So now coming to this, d are the inputs for 2 by 1. Here it is d bar. When C value is 0, output is equal to first input. So that is nothing but C bar d bar. C bar d bar plus when C value is 1, it is C d bar. Okay. So C bar d bar plus C d bar, we can take d bar as common. C bar plus C of d bar. So finally we will get d bar. So what is input I am getting as I naught? D bar, just simplification. You can get the d bar. Okay, na? Here it is 0. Here it is 0. And what is the input here? When C value is 0, it is D. So that is a C bar D plus CD. Here we can take D as common. So C bar plus C of D is common. So 1 dot D is D. So the input we are getting is D. So for this multiplexer, first input is D bar, last input is D, remaining two inputs are zeros. Am I right? Okay. Now whenever A and B values are 0, 0. Okay, something like this I am writing. So A bar, B bar, selection line 0, 0, it is equal to first input. What is the first input? D bar. And remaining two, we no need to consider. Whether it is A bar, B or A, B bar, we are getting 0. So these two becomes 0. And last combination is 1, 1 combination. 1, 1 combination is AB. AB and output is equal to last input. What is the last input? D. So A bar, B bar, D bar plus ABD. You see how dangerous the options are? A bar, B bar, D bar, ABD. So option D is correct because none of the options are matching. So option C, you see A bar, B bar, D it is. ABD is there. So blindly if you choose option C, it would be wrong. It is A bar, B bar, D bar. So option D is the right option here. I hope you have understood this. Is it clear? Yes. Jamal Ahmad, you can verify this answer once again. It is not C. So by mistake you have selected C because it is a D bar. In the option C there is A bar, B bar, D. Okay. You see how dangerous the options are. Okay. So you have to be very careful in choosing the options. Right? Shall I go for the next question? Please confirm me once. Is it clear? Okay. And don't think that this is only the chart we are making. So after the class, for yesterday's class also, many of the people are making comments and asking some questions and I am replying it. Okay, I hope some of you might be attended yesterday's class also. So in a similar way, for today's class also, you can continue in the comment box. So whatever the doubts related to this session, don't bring other sessions. So related to this session, so that the thread will be same and I can answer those things. Understood? And this is not only for today, it is till your examination. I will try to support you for getting the better score in the NIELIT. As far as the digital logic the things are concerned. And after this, the CO also I am starting, COA series also. So there we will discuss the CO questions. Okay. Now coming to the fifth question. Okay. Yes. Are you covering a sequential circuit? Please share your thoughts on the same. Definitely, Anil. Actually, sequential circuits tomorrow we are having sequential circuits. Okay, today combinational circuits. Tomorrow evening 5 p.m. We will discuss the sequential circuit is there. You can attend that. Tomorrow sequential circuit. Only 3 sessions for the digital. 3 sessions for CO is planned for me, and those things will be discussed. Okay, fine. Now coming to the next. Fifth question. Okay, the function realized by the following circuit is. The function realized by the following circuit is. Okay. Now you observe carefully. Selection lines are one is A, other is B bar. This is not B. This is B bar. So accordingly, we have to opt for the answer. Understood? Yes. Okay. Okay, fine. Now, whenever these are 0, 0, so A value, B bar value. 0, 0 means it will become, actually he has given first selection line as A, second selection line as B bar. So when both are 0, 0, it will become A bar B because B bar complement. 0 1 means A bar B bar. 1 0 means A B. 1 1 means A B bar as it is. So these are the values for the 4 operations. Now what is the value of this output? AB whole bar. AB whole bar is nothing but A bar plus B bar. Here also A bar plus B bar. Here AB. Here AB. Now I am writing here. So when the selection line value 0 0, it means that it is 0 means A bar. B bar complement is B. Of output is equal to first input. First input is I naught. What is I naught? That is A bar plus B bar. A bar plus B bar. Okay. Plus 0 1. 0 1 means A bar B bar as it is. So for this also we are getting A bar plus B bar. Plus what else we will get? 1 0. Okay. 1 0 means AB. AB of AB only we are getting. And 1 1 means AB bar. AB bar of AB. Because AB is the last one for these two. Now if we simplify this, what will happen is A bar B A bar is nothing but A bar B. A bar B. Again A bar B B bar is nothing but 0. Okay. Plus A bar B bar A bar. So it is A bar B bar. Plus A bar B bar B bar. It is also A bar B bar. So 2 times we got, only 1 time we can write. So this can be written as AB into AB. That is AB. B bar B cancel. It will become 0. AB will be there. Okay. Now coming to this, we can take A bar as common, right? Okay. So we can take A bar as common. B plus B bar plus A bar B bar plus AB. So 0 0 0 1 A bar plus B bar. AB whole bar is nothing but A bar plus B bar. A bar B bar A bar is A bar B bar. We have written. And A bar B bar B bar is A bar B bar only. Plus AB is written. A bar B A bar is nothing but A bar B. A bar B B bar becomes 0. Okay. So now if you observe this, what is required here? So I have written A bar of B plus B bar. So this is becoming A bar plus, I am writing here simply A bar plus A bar B bar plus AB. A bar B bar plus AB. So I can take in these two A bar as common. So A bar of 1 plus B bar plus AB. 1 plus B bar becomes 1. So it can be written as A bar plus AB. So A bar plus AB further can be written as A bar plus A into A bar plus B. A bar plus A becomes 1. So finally you will get A bar plus B. That's all. So A bar plus B or B plus A bar both are same. So option A is the right option. I hope it is clear. Okay. Now fifth question is done. Let us move on to the next question. The Boolean expression for the output F of the multiplexer shown below. What is the Boolean expression? So most of the questions what I observed in the NIELIT and other exams. So analysis on the multiplexers only, majority of them are given. That's why I brought more questions on the multiplexers. And there are some other questions also on decoders we will discuss. So yes. So we are getting PQ as the selection lines. It's very simple. When PQ are 0, so P bar Q bar, so output is equal to R. First input 0 0. 0 1 means P bar Q, output is equal to R bar. So P Q bar 1 0, output is equal to R bar. Third input. When both are ones, so PQ, output is equal to R, like this. Now if you take from these two, P bar you can take as a common. So I can take P bar of Q bar R plus QR bar. Plus from these two I can take P as common. P common means Q bar R bar plus QR. So from this, what we can do, this is P bar of Q exclusive R, because Q bar R plus QR bar is nothing but Q exclusive R. Then this is Q bar R bar plus QR is nothing but Q exclusive R. So if you see, this is something like A dash B plus A B dash, because XR complement becomes XNR now. So this is A bar B plus A B bar means P exclusive R, Q exclusive R. So finally I can write this as a P exclusive R, Q exclusive R. So that is option B is the right option. Yes, exactly. You are right. Exactly. That is correct. Option B is the right option. Vishnu, Sanket, Swati, Anku, Kashyap. You are right. Coming to the next question, 7th question. I hope everything is clear for you. So the 7th question, the total number of 2x4 line decoders with enable input are required to construct a 4x16 decoder is. So 2x4 decoders we have to use, but we have to construct the 4x16 decoder. How many decoders are required? So quickly you can tell. You can also quickly I will show you how to draw the 4x16 decoder circuit by using the enable input with the help of 2x4 decoders. Is it clear? Okay. So now let us see. So I will just give you the block diagram of 4x16 decoder. So how many inputs are required for a 4x16 decoder? 4 inputs and 16 outputs. Usually the decoder sizes will be like n into 2 power n. So 4 into 2 power 4. So 4 inputs. If 4 inputs are 0, 0, 0, 0, one output will be 1, 0, 0, 0, 1, other output, like that, total 16 combinations will come. In the presence of enable, output is equal to based on the input combinations. That is in the presence of enable. Okay, something like this. So I wanted to have a 16 outputs, right? So definitely in one line I have to take 4 2x4 decoders like this. 4 2x4 decoders you have to take in the first column. To enable or disable, because multiple outputs should not be selected. Out of all these, only one output should be selected. Out of 16 outputs, only one output should be 1. Remaining all should be zeros. So 4 2x4 decoders we can take initially. So this is 2x4. This is also 2x4. 2x4 and 2x4. So there will be 2 inputs. So let us take those 2 inputs as something like A0 and A1. So those are commonly connected to all the decoders. These are commonly connected to all the decoders. A0 and A1. And these are outputs from D0 to D15. Total 16 outputs. Actually, we have to take another 2x4 decoder. 5th one is also required, because multiple decoders should not be selected. When one decoder is selected, all other decoders must be disabled. So for this, another decoder is required. So finally it is acting as a A0, A1, A2, A3, total 4 inputs and 16 outputs. So these 4 outputs will be taken as a enable input for this. This output will be taken as a enable input for this. The third output is enable for the third decoder. Fourth output is enable for the fourth decoder. And for this also enable will be there. So this is disabled means entire outputs will be zeros. So like this, total we require 5 decoders. I hope you have understood. So option B is the right option. So we require 5 decoders for the construction of 4x16 decoder with the help of only 2x4 decoders. That's all. Okay. Coming to the next question, that is 8th question. The total number of 3x8 line decoders with enable line are required to design 6x64 line decoder in a similar lines. Very simple question. Now you could answer quickly. Yes, there are 2 levels. Shortcut cut is very simple now. In one line we can take. This is only a construction process I am explaining. It is a shortcut only, because in the first column you are taking 4 decoders, means in the mind you can assume that for 4 decoders to enable or disable, another decoder should contain 4 outputs. That is another 2x4 only. Exactly. Okay. So the number of 3x8 line decoders with enable line are required to design 6x64. So 6x64 is nothing but 8 8s is 64, right? So that means one 3x8 decoder can give only 8 outputs, right? 1, 2, 3, 4, 5, 6, 7, 8. But I want 64 outputs. Then we have to take 8. 1, 2, 3, 4, 5, 6, 7, 8. Like that, total 8 decoders you have to take. But 8 are not sufficient. This is the decoder number 1. This is the decoder number 2. And this is the decoder number 8. All are 3 by 8 decoders. This also contain 8 outputs. But there are 8 rows, definitely another 3 by 8 in a similar lines. How you have taken this? Another 3 by 8. So these are the 3 inputs commonly connected to all like this. It's a very rough diagram. 3 inputs for this also connected. And these outputs, these are connected. These 3 inputs, total 3 inputs. Okay, these 3 inputs, 6 inputs and 64 outputs. These are connected as a enable for this. So total we require 9 decoders. Very rough diagram. So 9 decoders, option A is the right option. I hope every one of you understood this and following this. Is it clear? Yes, most of you have sent 9. That is true. That is correct. Now this simple question I think every one of you could answer. Which of the following decoder size can be used to design a full adder circuit using the decoder? So I wanted to design a full adder. So for designing the full adder circuit, which decoder can be used? I think every one of you can answer this very simply. So full adder is a combination circuit. I will just briefly explain. So full adder is a combination circuit. It will take 3 inputs, 2 bits to be added and also previous carry. It will produce the sum and carry, right? So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. As a full adder is 8 combinations will come, definitely maybe 3 by 8 decoder is required. Sum is 0, carry is 0, sum is 1, carry is 0, sum is 1, carry is 0, 1 plus 1 is 2 means sum 0, carry 1, sum 1, carry 0, sum 0, carry 1, sum 0, carry 1, both are 1s. 1 plus 1 plus 1 is 3, 3 means 1, 1. So sum is 1, carry is also 1. Okay, so sum is an equation which is a sigma of 0, 1. Second min term is 1. 0, 1, 2, 3, 4, 7. 1, 2, 4, 7. Sum of min terms 1, 2, 4, 7. 0, 1, 2, 3, 4, 5, 6, 7. Okay. Similarly, carry is sum of what min terms? So 0, 1, 2, 3. 3, 5, 6, 7. 3, 5, 6, 7 is a carry equation. How many questions you will solve? So around 12 questions, Bhumi. How many questions you want? Because our duration is around maximum 50 minutes of duration this YouTube session. But still, any doubts related to this on the same chat box that is in the comment box after this class is over, you can send your doubts related to the combination circuits. In a same class related to that doubts also if you ask, so that it is great. Now we can cover 8 outputs, right? So better we use 3 by 8 decoder. I will tell you roughly how it is to be constructed. So 3 inputs for this 3 by 8 decoder. I can take X, Y, Z as inputs. Okay, and these are the 0, 1, 2, 3, 4, 5, 6, 7 are outputs, right? 0, 1, 2, 3, 4, 5, 6, 7. So we can take 1, 2, 4, 7 to OR gate. 1, 2, 4 and 7. So these are connected to OR gate. So you will get the sum 1, 2, 4, 7. So equation for sum. Carry is 3, 5, 6, 7. So 3, 5, 6 and also 7. So these will be output. Just very rough diagram. This is a carry. Like this, 3 by 8 decoder is sufficient for this. So option B is the right option. Exactly. Okay. Now coming to the next. What is the minimum number of NOR gates required to realize the function A plus BC? Try this. This is also synthesis of combination circuits only, because we have to realize the one function using the NOR gates. So what is that function here? A plus BC. How many NOR gates are required? If you are doing only the 2 input NOR gates, for example. Okay. So A plus BC, we can write this as a something like A plus B into A plus C, right? Both are same. a plus b into a plus c is same, na? Because from the distributive law, a plus bc can be written as a plus b into a plus c. So a plus b means if you take an OR gate, something like, if you take OR gate, you will get a plus b, and if you take NOR gate, a plus b whole bar you will get. And similarly, a and c, you can take it to another NOR gate. So this is a plus c, and if you complement it, it will be a plus c whole bar. And these two you can provide to as input for the another NOR gate. So this is also NOR gate. Now here we are getting a plus b whole bar. Here we are getting a plus c whole bar. A plus b whole bar, a plus c whole bar. So we are taking the OR operation and then complement, right? So output becomes, for example, f is output, for example. Output becomes, it is something like a plus b whole bar plus a plus c whole bar. And whole bar. Why whole bar? Because we are taking NOR. Now, something like a plus b whole bar, according to De Morgan's, a bar into b bar. A bar means a plus b whole bar and whole bar into b bar, a plus c whole bar into whole bar. A plus c whole bar means a plus c. A dash whole dash is a. Now a plus b into a plus c we got, no? That is nothing but a plus bc. That is nothing but a plus bc. We could realize with the 3 NOR gates. So minimum 3 NOR gates are required. Option A is the right option. Exactly. Most of you are sent. Yes. Aditya Desai. Yes. Never quit. Pratik Soni. Gopal Krishna. Yes. Now coming to the next question. 11th question. So here the selection lines are, one is x1. So this is x1 and this is x2. And there is nothing there here. You just don't consider this. And here it is I0, I1. So this is I0 and I1. So what is the function? In the form of x1 comma x2. Option A, f is independent of x2. Option B, f is equal to x1 dash x2 plus x2 dash x1. That is xr. And option C, f is equal to x1 bar plus x2. Option D, x1 bar x2 bar plus x1 x2. You can easily do this. Okay. So as for this, when the x1 value is 0, it is equal to 1. Something like this. So x1 bar dot 1, x1 bar dot 1 plus x1 0. Is it clear? x1 0. Okay. So x1 dot 0 is 0, x1 dot 1 is x1. So x1 bar. Finally, the output we are getting is x1 bar here. Okay. Now the input to this is x1. Okay. Now based on the x2 value, output is depending. If x2 value is equal to 0, so that is nothing but x2 bar. x2 value is equal to 0, output is equal to first input, that is x1 bar. Plus, if x2 value is 1, so that is x2, output is equal to second input. Second input is what? x1. So what did you get now? x2 x1, x2 bar x1 bar plus x2 x1. So this is equivalent to option D, because AB can be written as BA. x2 bar x1 bar or x1 bar x2 bar both are same. So option D is the right option. Exactly. Akash, Vrishab Pandey, x1 exclusive or exclusive NOR x2. Correct. Yes. Okay, na? Okay. Shall I go for the next? Okay. Now let us move on to the next question. That is the last question. I think it is the last question. The number of full and half adders required in a circuit to add the two 16-bit integers. Okay. So I wanted to add two 16-bit integers. How many full adders, how many half adders required? Something like this. For example, if you are taking 4 bits, 1011 or 1100. So bit by bit you are adding means initially I am adding 2 bits. When you get a carry, so including carry 3 bits we have to add. For the addition of 2 bits, we can use the half adder. For the addition of 3 bits, we can use a full adder. So that means for a 16 bits, like 16 bits in one particular number and 16 bits in another particular number. So for the LSB position, only half adder is sufficient because half adder adds only 2 bits. But next position onwards, full adders are required because carry will be produced. Initially, there won't be any carry. Okay. something like 1 1 1 1 0 1 0 1 for example. 1 plus 1 means 1 0. So now we got carry, 3 bits must be added. For a 3 bits definitely full adder. So 4 full adders, 1 half adder for a 4 bit addition. But 16 bit means we require 15 full adders must, and 1 half adder is required. So that option B is the right option for this. Okay. So this is all the questions of the combination circuit. It is not an ending of this session. Don't think like that. Tomorrow we are having same 5 o'clock sequential circuit will be there. But any doubts related to combination circuit till your exam, I will try to help you. I am here to clarify your doubts in the comment box. You can make. Okay. Now, just before concluding the session, let us congratulate our Gradeup achievers in the ESE Engineering Service Examination and also the GATE examination. In the year 2020, that is the most recent, 60 plus Gradeup students are top in top 100. So those are CS 4th rank we got, and 20th rank we got in the computer science, and also 39th rank we got 2 persons, and 47th rank. So more ranks we got in CS. And also engineering services in the 2018 ECE we got first rank, top rank. 2019 also mechanical we got 10th and 27th ranks. So let us congratulate all these toppers, and I hope every one of you also be on this board in future. Okay, so let us work on that direction. Now coming to this Gradeup Super. Gradeup Super is a one-stop solution for all your preparation needs. So once if you are subscribed to the Gradeup Super, you can access unlimitedly all these structural live courses. You can have an access to the India's best faculty with complete doubt resolution and also full coverage of syllabus. With a green card, online mock test will be conducted. All these are designed by the toppers based on the latest pattern. And if you have any doubts related to the Gradeup Super, how to subscribe and everything, you can reach us at 96500 52904. Okay. So and also related to the Gradeup Super subscription, Gradeup Super is a very good thing for preparation needs of an engineering students. Okay, because this is having a lot of offers here right now, and you may not get in future for those things. Please hurry up to join if you wanted to join any of the courses. I have already mentioned what are the courses we are offering. Okay. So these get in access to preferred live courses with the Gradeup Super. Go to the Play Store, download the Gradeup app and subscribe to the Super. For a 6-month subscription, you have to pay around 2,000 per month and total of 12,000 rupees, 2,000 per month only. And for 12-month subscription, you have to pay per month 1,400 rupees and a total of 16,800. For 24-month subscription, you have to pay per month 1,000 rupees and a total of 24,000. So I can personally feel it is a very less in fees as far as the engineering subjects are concerned. Okay, and you can mail us at help@gradeup.co for any doubts related to this course, or you can also reach us at 96500 52904. So that's all about this Gradeup Super and the subscription. And I hope you enjoyed the session. Try to continue commenting in the comment box. Try to subscribe the YouTube channel. We are having more than 3 lakhs subscribers. Please hurry up to subscribe to the channel and get an advantage of all these free classes. And also you can get Gradeup Super subscription, very limited cost. I told you the fee structure and everything. And try to join this, subscribe to this Gradeup Super also. So till then, bye. We shall meet tomorrow at 5 p.m. with the sequential circuits. And the series will continue. After this, we will start the computer organization and architecture also. So till then, bye. Good night. Have a great night. And prepare smart. Go Gradeup, prepare smart, score better, and stay safe. Thank you. Thank you, one and all. Good night.